Painite. Painite is the rarest mineral on Earth, a title it held without competition for nearly half a century. For 44 years following its identification, the total number of confirmed specimens in existence was 3. 3 stones, in the entire world, from a single valley, in Myanmar. Its chemistry is the reason. Painite forms when boron and zirconium, two elements that almost never occupy the same geological space, are forced together under specific hydrothermal conditions inside pegmatite rock. The result is a hexagonal crystal with a hardness of 8.5, a deep orange to brownish red color produced by trace chromium and vanadium, and a specific gravity above 4.0. Gem quality stones command between $50,000 and $60,000 per carat. Approximately 24 faceted stones exist globally that meet elite clarity standards. Myanmar remains the only confirmed source. Red diamond. The red diamond is chemically identical to a colorless diamond, pure carbon, nothing else. Its color is not caused by an impurity, it is caused by a structural defect. Deep in the Earth's mantle, the carbon lattice is subjected to shear stress so intense that the atoms are pushed out of their normal alignment. These glide planes selectively absorb green light and transmit red, producing the most expensive gemstone on the planet by weight, reaching $2.5 million per carat for certified specimens. During the entire 37-year operational life of the Argyle mine in Western Australia, fewer than 100 carats of red diamonds were recovered from over 865 million carats of total production. Most years produced 1 to 3 specimens, the majority smaller than a grain of rice. Fewer than 30 certified red diamonds above 0.5 carats are known to exist. The Argyle mine closed permanently in 2020, ending the only consistent geological source the world has ever had. Benitoite. Benitoite occurs in gem quality in one place on Earth, San Benito County, California, inside a narrow belt of blue-schist metamorphic rock formed by the subduction of oceanic crust. The chemistry responsible requires high pressure, combined with unusually low temperature, a geological contradiction that has produced this barium-titanium silicate nowhere else at commercial scale. Its dispersion, the ability to split white light into spectral color, measures between 0.044 and 0.047, higher than diamond. Under shortwave ultraviolet light, it fluoresces an intense chalky blue, reliable enough to function as a diagnostic test. The world record cut stone is 15.42 carats, a statistical outlier given that most crystals never reach a usable size. The sole commercial mine exhausted its primary veins in the late 1990s, and no new deposit has been identified since. Alexandrite. Alexandrite presents as two entirely different colors depending on the light source. In daylight, it appears emerald green. Under incandescent light, it shifts to raspberry red. This is a property of the chromium ions in the chrysoberyl lattice, which absorb so precisely at 580 nanometers that the stone sits at the exact boundary between two transmission windows in the visible spectrum. Daylight pushes perception toward green. Artificial light pushes it toward red. The chromium required must form inside a beryllium-bearing metamorphic rock, a pairing that almost never occurs because the two elements follow different geochemical pathways through the crust. The original Russian deposits in the Ural Mountains were exhausted within decades of their discovery. A natural alexandrite, above 5 carats, with a strong color change, is rarer than a diamond of equivalent size. Most commercial jewelers will never handle a genuine specimen in their careers. Red beryl. Red beryl is estimated to be 150,000 times scarcer than gem-quality diamond, and the only commercial source ever identified is a single mine in the Wawa Mountains of Utah. Most beryls grow in pegmatites. Red beryl did not. It formed when beryllium-rich volcanic vapors, released as rhyolitic lava cooled and fractured approximately 22 million years ago, encountered manganese-rich groundwater inside those fractures. The manganese produced the raspberry red color. The environment also had to be almost entirely free of calcium, or the beryllium would have bonded into different minerals. Crystals rarely produce faceted stones above 2 carats. Prices reach $10,000 per carat for clean material. Taphite. Taphite is the only mineral discovered first as a faceted gemstone, rather than as rough material. It was found in a Dublin jeweller's lot in 1945, already cut and polished. Misidentified as spinel. Only a refractive index measurement revealed it was something entirely different. It forms in high-temperature metamorphic environments where beryllium and magnesium are concentrated together, a combination rare enough that the total global supply of faceted taphate could be transported in a coat pocket. The stone is estimated to be approximately 1 million times rarer than diamond. Despite this, it remains undervalued relative to its scarcity because it lacks the public recognition of stones with established marketing histories. Musgravite. Musgravite is visually indistinguishable from taphate without laboratory analysis. Raman spectroscopy, or X-ray diffraction, is required to separate them. The difference lies in the ratio of beryllium to magnesium and the stacking of the oxygen layers in the crystal. To the naked eye, they are the same stone. In terms of rarity, they are not close. Musgravite is significantly scarcer, making it one of the 3 rarest gemstones on Earth by any documented measure. First found in the Musgrave Ranges of Australia in 1967, it has since appeared in Sri Lanka, Greenland, and Antarctica in quantities too small to affect the market. Faceted stones above 1 carat are exceptional. Prices exceed $35,000 per carat for quality material. Grandidiorite. Grandidiorite is a blue-green mineral found primarily in Madagascar. Its trichroism is the defining property. The crystal transmits 3 distinct colors depending on the viewing axis, appearing dark blue-green, colorless, and dark green as the stone is rotated. In transparent form, it is extremely rare. The vast majority found in nature is translucent or opaque and has no value as a cut stone. Prices for fine transparent material range from $5,000 to $20,000 per carat. Supply from Madagascar remains unpredictable due to the remote and irregular nature of the mining operations, and the stone has only gained meaningful collector recognition in the past 2 decades. Jeremejevite. Jeremejevite is an aluminum borate that is routinely misidentified as aquamarine in the field. It carries piezoelectric properties, meaning it generates an electrical charge when subjected to mechanical stress, a physical behavior shared with quartz and tourmaline. It only began producing gem-quality crystals of significant size when deposits were found in Namibia in the 1970s. Faceted stones above 5 carats are exhibition-level specimens. Prices for fine blue material reach $30,000 per carat. It remains almost entirely unknown outside specialist circles, which keeps prices lower than comparable rarities, but does not change how little of it exists. Poudretite. Poudretite spent decades as a scientific footnote. First identified in 1965 from microcrystals in Quebec, too small and fractured to cut, it remained a laboratory curiosity until 2000, when mining in Myanmar produced the first faceted specimens. The largest known example, a 9.41 carat stone, held by the Smithsonian Institution, remains the most significant specimen in existence. The mineral forms in a complex environment requiring potassium, sodium, boron, and silicon in proportions that rarely converge, and there is no consistent supply. Prices range from $3,000 to $10,000 per carat. As identification technology becomes more accessible, stones sitting in collections as unidentified pink minerals are occasionally confirmed as poudretite, adding fractionally to the known global count.